This video is going to address how to solve a system of linear equations using the graphing method. The graphing method is probably the least accurate of the three methods because oftentimes it requires you to estimate the point of intersection. I would strongly encourage you to use a graphing calculator to do these problems. If you try to do them by hand and create all the graphs, it's going to be very time consuming. If you don't own a graphing calculator, you can download an app from wabbitemu.org that basically looks like a TI 84 Plus calculator and works just the same. And I'm going to be using that throughout this presentation. The process for graphing or solving a system by graphing is you have to graph the first equation as well as the second equation on the same coordinate plane. Now, one of the challenges is in order to graph it using the graphing calculator or even the WabbitEmu website is you have to have the equation in the proper form. And the proper form for putting it into the graphing calculator is y equals mx plus b. So we have to actually solve the given equations for y if they're not already solved. And then we want to look for the point of intersection if there is one. And we typically for systems, we want to take the extra time to check our solution in both equations as well. So let's take a look at an example. We have x plus 2y equals 7 and 2x plus 6y equals 12. And so the first thing I need to do is go off over here to the side and solve these two equations for y so that I can enter them into my calculator. So I have x plus 2y equals 7. Subtract x from either side to isolate the y. So I have 2y equals 7 minus x. Then I divide by 2 all the way across. So I have y equals 7 halves minus 1/2 x. Then I'm going to do the second equation using the same process. I have 2x plus 6y equals 12. Subtract 2x from either side. I have 6y equals 12 minus 2x. Divide all the pieces by 6. Simplify, we have y equals 2 minus 1/3 x. And so once I have those two equations solved for y, I'm going to enter this equation and this equation into my graphing calculator. All right, so here we go. Y equals, turn the calculator on. We have y equals, and I'm going to clear the equation that is in there. And we enter 7 divide 2 minus 1x divide 2. And we enter, and then we're going to enter the second one. 2 minus 1x divide 3. And then I'm going to tell it to graph. And it's kind of difficult to see. So one of the things you can do, if you can't see it real well, is use the zoom. Zoom is like the viewfinder on your camera. So if I press zoom and I want to get closer, so I want to zoom in, which is option 2. And then I can kind of keep hitting enter till hopefully I get to a point where I can see it. Looks like I went the wrong way. So let's try zoom out so I can get a little bit further away and maybe get a better picture. Again, this is the downside for using the graphing calculator. So one of the other things I can do is maybe look at the table of values and look and see where the value for the first equation and the value for the second equation is the same. And if I do that, I can see that it occurs when the x value is 9. I have y is -1 and y2 is -1. So I would suggest that my solution to this problem, or the point of intersection, is 9, -1. And I can verify that by substituting into the given equations. So 9 plus 2 times -1, we hope is 7. So that's 9 minus 2, which is 7, which does equal 7, so it works in the first equation. That's good. Then we have 2 times 9 plus 6 times -1, and we hope that that equals 12. So we have 18 minus 6, which is 12. 12 equals 12. It works in both equations. Therefore, I know that the point of intersection and the solution to the system is the ordered pair 9, -1. All right, let's look at another one. Again, the first thing we have to do is solve the equations for y. So we have -x plus 2y equals 4. So I'm going to add x. I get 2y equals x plus 4. Divide everything by 2. So I have y equals 1/2 x plus 2. Okay, then we go back and we do the second equation. So we have 2x minus 4y equals 1. So we subtract 2x from either side. So I have -4y equals -2x plus 1. Divide everything by -4. So I have y equals positive 1/2 x minus 1/4. Once I have them solved for x, we're going to enter them into the graphing calculator. So I need to clear out everything that I had entered previously. And I also want to put my screen back to the regular size window. To do that, you press Zoom 6. That's going to give you the standard window. So we enter 1x divided by 2 plus 2, enter. Then we enter the second one. 1 divide 2, 1x divide 2 minus 1 divide 4. Okay, so when we look at these, let's see what happens. Okay, it appears we have parallel lines, and when you have parallel lines, they don't intersect. So if there's no point of intersection, there's no point in common, which means this system has no solution. And one of the reasons you could tell that really by looking at the equations, because if you'll notice, the slope of the first equation and the slope of the second equation are the same. And remember, lines that have the same slope are parallel, which in the case of a system implies there's no solution. Finally, let's look at a third one. Again, we have equations. We need to solve them for y. So I have 3x minus 2y equals 5. I'm going to subtract 3x, So I get -2y equals 5 minus 3x. Divide everything by -2. So I have y equals -5/2 plus, because negative divided by negative is a positive, 3x over 2, or 3/2 x. All right, then we do the second one. We have negative 9x plus 6y equals negative 15. We add 9x. We add 9x. Divide, so we get 6y equals negative 15 plus 9x. We divide everything by 6. And so I have y equals, I'm going to simplify, negative 15 and 6 both divide by 3, which gives me negative 5 over 2, plus 9 and 6 again divide by 3, so 3x over 2. And so then I go out to my equation or to my calculator, and I'm going to graph those two equations. Again, I go in and I clear out what I had in there previously, and I enter negative 5 divide 2 plus 3x divide 2, enter, and then I enter the second one, negative 5 divide 2 plus 3x divide 2. Now, as you're typing that, you may realize, Miss Ralston, that's the same two equations. And yes, it is. And so visually, when you graph it, it's going to appear as a single line. So these two particular equations coincide visually, and so it's one line. So basically, you have an infinite number of solutions. Any pair, any ordered pair that you can find that makes the statement true would be a solution. And there's lots of different ways for writing that, so you may want to take a look at the exercises to see how ECOR wants you to write them.